Time for section 4-4. We're learning about properties of logs. These properties you definitely need to memorize. They will carry over into pre-calculus, and it will be expected that you know and remember these when you step into that class. So the first property, I'm just jump right in. These properties are true for any base. So as long as the bases are consistent through the whole thing, they could be 2, 3, 4, 5. They could be E, so they're true for natural logs as well. I'm going to write them as a generic base B. And the first property is if you are if you're adding two logarithms, that's the same as taking the log of the products of the two things that you're logging. So basically, you can shove addition together in multiplication. Now, let me write what this is not. I am not saying that the log of one thing plus the log of the other thing is the log of the one times the log of the other. Okay, this is not what I wrote. This is the number one problem with these with this property is people want to write this. They want to specifically, they like to go this direction. I have two logs multiplied and they want to split them with addition. That's not how it works. The log on this side is written only one time, not on both of the parts. Okay. Second property, if I have the log of two things subtracted, that's the same as the log of both things divided. Okay, in my weird brain, that makes sense. Subtraction kind of goes along with division for me and addition and multiplication pair. Now, let me show you what I did not write. I did not write this. If you subtract two logs, it is not equivalent to one log divided by the other. I only wrote log one time in this, and the most common error with these properties is going this direction. People want to take the log of two things divided and split it in subtraction, and that is illegal. Okay, you will get a little black magic mark on your paper if you do that. And the last property, probably the most powerful of the three, in my opinion, is that if you have the log of something to a power, you can bring that power down in front. It's kind of a weird property. But what is so valuable, and you'll use this property all the time in calculus, what's so valuable is you can take something that's an exponent and bring it down on ground level where you can do normal algebra with it. And that's a really powerful tool. Okay. Now, the power has to be on just on this thing that you're taking the log of. It's not around the whole thing. So let me show you what I did not write. I did not write that this to some power where the log is being taken to the power is not equal to sorry, these are not equal to the log of b of m. Okay, this is illegal. The power has to just be on the thing that you're taking the log of. All right, what we're doing in this section is we're just going to practice these properties. So your homework's going to start by saying write as a single logarithm. So it'll have a big string of stuff. Let's say log base 3 of x plus log base 3 of y minus 5 log base 3 of z. something like that. And the idea is that you are going to use these properties above to push these together. So here's the kind of order of operations for logarithms. If you imagine that, here's how I like to say it. Each of these is a car, okay? There's my car. You've got 3 cars because there's 3 terms right here, okay? And the numbers that are in front of the logs are the people. Now what's going to happen is all of these cars are going to crash together, okay? And you don't want to squash the person in the middle of the car. So the first thing that you have to do is get the people out of the way. So you need to take this 5 and pull it up as a power before you crash the cars together. Otherwise you squish the people, okay? I don't know when or where I thought of that, but there you go. So my first step is to take any numbers in front of the logs and I pull them up as powers. Okay, no smashing of people. And now you're going to push these together and you're going to do it from left to right. So I'm going to take these, and you can do this all in one step if you start to see it, but I'm going to do it one at a time. Addition turns to multiplication. I do not write the log twice. Only the x and the y get multiplied and I write 1 log. And then the subtraction right here becomes division. So I write 1 log xy over z to the 5th. Now, how do you know when you're done? You're done when you've written log only 1 time. All right? So if you still got like a log here and a log there, you're not done yet. You've still got more to push together. Okay, let's do another example of those. Let's do this problem right here. So logs kind of they follow the same rules as of algebra as you've all come to know and love. So whenever there's parentheses, it means do this first or distribute. The distributive property applies with logs. And so since these cannot be combined, now why? Because, well, they could be first. I guess we could do this first. The 6 needs to get out of the way, okay? And then you could plug these in, push these together in multiplication. That would work. Or you can take this 3 and distribute it in first and then push them together. It doesn't really matter. Just like in algebra, you can add like terms in the middle of the parentheses first, or you can distribute the number from the outside first. It doesn't matter how you do that. I am going to distribute the 3 in first. And when you distribute, then you drop your parentheses. Then I'm getting my people out of the way because I'm getting ready to crash cars. Okay, so I'm pulling the 3 up and the 18 up. So I get log x to the 3rd, log y to the 18th. Quick question while we're doing this. What's the base on this log? It's a great question, huh? You would be right if you said 10. When I don't write a base, that means it's base 10. All right, now I'm going to shove these together. This is looking a lot like the previous problem now. These are going to go together in multiplication. And then subtraction is going to go together with division. So I've got x cubed y to the 18th over xy. Now sometimes at this point you can reduce. Please do that. In algebra land, we know how to reduce this fraction. The x here cancels with one of the x's here. This y cancels with one of these. And I am left with log of x to the 2nd and y to the 17th. Okay. Now, a quick word about notation. If you have the log of two things added, let's say x plus y, you have to put parentheses around that. If you don't, what this is the log of x and then plus y, not the log of the sum itself. So make sure that you put parentheses on if you use addition or subtraction. Those are the same. However, if you have two things multiplied or divided, they don't require parentheses. It's not wrong to put them on. This is fine. You just don't need to because they're assumed to be connected, which comes to this point. If you want to write y times log of x, you have to put the y in front. If you put the y in back, then it is assumed to be part of what's being logged, which is incorrect. So there's some kind of tricky notational things along here. So pay attention to the answers in the back of the book and make sure that you're getting your parentheses in the right place and your notation's correct. I will mark you off if you're supposed to write this and you write this. That will lose you points if you don't put parentheses. So be careful. Okay. That's the first half of your homework, is taking these expanded expressions and contracting them into one. The second part is to do the opposite. It'll say expand, and it'll give you one little concise thing. So let's say the natural log of x times the square root of y. So this is one log and we want to pull it apart. Okay, so that means the people are already out of the way, they're already in the power position, and I want to pull them apart and bring the people down in between the cars. Okay, so the first thing I do, it's kind of, it's like order of operations here. This multiplication right in the middle of here is the first thing that takes precedence. So that means I'm going to pull this apart with addition. And then I look at each term and say, do I need to pull anything else apart, or are there any powers? Well, this root is a power. Whoops. This is a power of 1/2, which means that 1/2 is going to come down in front. So it's exactly the opposite of what we just did. Previously, it was people up, then smashed together. Now it's pull apart, people down. All right, let's do another one. Okay, what's happening here? Well, the outside function that's happening is this cube root. What is that? That's a power to the 1/3. So that's on the outside, so that's got to happen first. So that's coming down in front. And then the question is there anything else you can do? Don't get sucked in. The answer is no. This is it. We do not have a property that says the log of two things added is something magical. They have to be multiplied. Now, what about these guys? These are multiplied, but that's a part of the whole. The property says that the whole thing has to be operating in multiplication. So this sign in the middle has to be multiplication. Otherwise, the property doesn't work. So there are some tricky things in these problems like that. They're trying to get you to step outside the bounds of the property. So be careful with that. Here's another one that trips a lot of people up. Okay. So what's happening here? Out on the outside function, I've got multiplication between these two. So that's what I'm doing first. The log of the first thing plus the log of the second thing. Now within the second thing, I've got addition. There's no property to pull apart addition. So this does not pull apart anymore. But here's where people want to go rogue. They see this squared and say, oh, that 2 is going to come down in front. That is black magic. All right. The reason is because the 2 is operating on the x only and not this constant term over here. Okay. So this is actually done. Now, if it looked like this, now that 2 would come down. But because it's inside the parenthesis on only part, it does not come down in front. So these two are kind of like little tricky things. Be aware that those are in there and try some of these. This is a practice section. And then we will learn how to use these and what they're for in the next section.